All right, so today we're going to do a deep dive into something that you might find pretty interesting as someone who's already familiar with relational databases. We're going to talk about NoSQL databases.
Yeah.
So imagine, if you will, trying to fit all of Facebook's data, like all the posts and connections and everything, into neat little rows and columns. It just wouldn't work right. It would be a complete mess. So that's where NoSQL comes in.
Yeah, that's a great way to put it. The world is generating data these days that's very messy. It's very interconnected, and it's just plain massive. You think about all the social media posts that are out there, the sensor data from your phone, video streams, all that stuff. It's not the kind of data that fits neatly into tables. Mm-hmm. And that's why NoSQL databases were developed.
Okay, so NoSQL, does that really mean no to SQL?
Yeah.
I have to admit that the name is a little intimidating.
Yeah, it's a bit misleading, I'll admit. It's more like not only SQL. NoSQL databases aren't about just throwing SQL out the window. They offer a different approach to managing data, one that prioritizes flexibility and scale. So instead of forcing everything into tables, NoSQL databases offer different ways to store and access information.
So if we're not talking about tables and rows, then what are we talking about? What does a NoSQL database actually look like?
Well, there are actually a few different types of NoSQL databases, each with its own unique structure. So let's start with key value stores. Imagine a giant dictionary where each entry has a unique key and a corresponding value. It's very simple, but incredibly powerful for certain types of data.
Ah, okay, so kind of like a lookup table. When would you actually use a key value store in the real world?
Absolutely. So think about something like a shopping cart on an e-commerce website. You need to quickly store and retrieve items based on a unique identifier, like a product ID. A key value store is perfect for that. It's fast, it's efficient, and it scales really well.
Okay, that makes sense. So key value stores are all about speed and simplicity. What other types of NoSQL databases are out there?
Next up, we have document databases. These are a bit more complex than key value stores. Instead of just storing a single value, you can store entire documents. These documents can be in formats like JSON, which are very flexible and can hold all sorts of information, text numbers, even nested objects.
So it's more like storing a whole file instead of just a single data point. When would you choose a document database over a key value store?
Exactly. A document database is a great choice when you need to store more complex data that has varying structures. Think about something like a social media post. It might have text, images, likes, comments, all sorts of different elements. A document database can handle that complexity very easily.
Interesting. Yeah, I'm starting to see how NoSQL databases provide a lot more flexibility than a traditional relational database. What other types are there?
Let's talk about column-oriented databases. These are interesting because they kind of flip the script on how data is stored. Imagine a spreadsheet with countless columns, and each column can be accessed independently.
So instead of rows and columns, it's more like a collection of columns. How does that actually benefit you?
Well, think about analyzing data. That has a lot of attributes.
Yeah.
In a column-oriented database, you can very efficiently retrieve data for specific attributes without having to read through entire rows. This makes them perfect for things like analytics and reporting.
Okay, I'm seeing how this could be really useful for data analysis. This is all making a lot more sense now. Is there anything else?
The last type we'll discuss today is graph databases. Now, these are fascinating because they focus on relationships. Imagine a network of nodes connected by edges. Each node represents an entity, and the edges represent the relationships between them.
So it's all about understanding how different pieces of data are connected. This sounds perfect for something like social networks.
Exactly. Graph databases are incredibly powerful for understanding relationships and patterns. Think about a social network like Facebook. A graph database can easily represent all those connections between friends groups and posts.
Well, this is really eye-opening. We've gone from key value stores to these complex networks of relationships. It seems like NoSQL databases cover a lot of ground. But how do they actually compare to the relational databases that I'm used to? What are the real differences?
Well, that's the key question, isn't it? Relational databases, they've been the go-to for decades, and for good reason. They're built on these solid principles: ACD properties, atomicity, consistency, isolation, and durability. These properties ensure that data is always consistent and transactions are reliable, which is crucial for things like banking or financial systems.
Okay, so ACD properties are all about making sure that the data is like rock solid and reliable. But where do NoSQL databases fit in? Do they just throw those principles out the window?
Not exactly. NoSQL databases prioritize different aspects like high availability and scalability. They often follow what are called base properties, basically available soft state and eventually consistent.
Base properties.
Yeah.
That sounds almost like the opposite of ACID. Can you unpack that a bit? What does that actually mean for how data is handled?
Sure. Let's say you're browsing an e-commerce site, and it's using a NoSQL database. You might notice that a product's price or availability updates a little bit later than you might expect. That's because NoSQL databases prioritize keeping the system up and running, even if it means some data is temporarily out of sync. Eventually, everything will catch up and become consistent.
So it's a trade-off. You gain speed and flexibility, but you might have to deal with some temporary inconsistencies. I mean, are there situations where this trade-off makes sense?
Absolutely. Think about social media. Would you rather have a platform that's always up and running, even if some comments appear a few seconds later, or a platform that's constantly going down for maintenance to ensure perfect data consistency?
I think I'd prefer a platform that's always available, even if it's a little messy sometimes. It seems like there are fundamental differences in how relational and NoSQL databases approach data. Is there a way to understand these differences in a more structured way?
There is. It all comes down to this concept called the CAP theorem. It states that in a distributed database system, you can only guarantee 2 out of 3 things: consistency, availability, and partition tolerance.
Okay, break that down for me. What exactly do those terms mean?
Consistency means that everyone sees the same data at the same time. Availability means the system is always up and running, even if there are failures. And partition tolerance means that the system can handle network interruptions without completely falling apart.
So it's like a triangle, and you can only pick 2 sides. How does this relate to relational and NoSQL databases?
It's exactly. Relational databases, with their emphasis on ACD properties, they typically prioritize consistency and availability. They might struggle with partition tolerance, meaning a network issue could cause downtime. NoSQL databases, on the other hand, often prioritize availability and partition tolerance, leading to that eventual consistency we talked about earlier.
So that's why NoSQL databases are better suited for handling large distributed systems, where downtime is simply not an option. It seems like choosing between a relational and NoSQL database is like making a fundamental choice about what you prioritize. But how do you know which approach is right for a particular project?
That's a great question, and it really depends on the specific needs of the application. If you need absolute data consistency, and transactions are absolutely critical, a relational database is probably the way to go. But if you need to handle massive amounts of data, you need high availability, and you can tolerate some eventual consistency, then a NoSQL database might be a better choice.
Okay, this is all starting to click into place. But we've been talking about NoSQL databases in general. Let's zoom in a bit. Are there any real-world examples of companies using these different types of NoSQL databases successfully?
Of course. Let's start with key value stores. Companies like Amazon use them extensively for their shopping cart functionality. It's the perfect solution for storing and retrieving simple data very quickly and efficiently.
So key value stores are the go-to for fast, simple data operations. What about document databases?
Think about a company like Netflix. They use document databases to store all the information about their movies and TV shows, titles, descriptions, actors' ratings. The flexible structure of document databases makes it very easy to manage all that diverse data.
So document databases are great for managing complex data that doesn't fit neatly into rows and columns. What about column-oriented databases? What are they best suited for?
Companies like Facebook use column-oriented databases to analyze massive amounts of user data. They're great for tasks like counting how many times a particular post was shared or analyzing trends in user behavior.
Okay, so column-oriented databases are the heavy hitters when it comes to data analysis. What about those fascinating graph databases we talked about earlier? Are there any real-world examples of those in action? They sound like they're straight out of a sci-fi movie. Are they actually being used in the real world?
Oh, yeah, they are. Think about LinkedIn, for example. They use a graph database to map all the connections between people, skills, and jobs. It allows them to create those personalized recommendations and suggest potential connections you might find valuable.
So graph databases are all about making sense of complex relationships. This has been like a whirlwind tour of NoSQL databases. But as someone who's used to relational databases, I'm still kind of wondering, how do I actually choose the right NoSQL database for a specific project?
Well, choosing a database is kind of like choosing the right tool for a job. You wouldn't use a hammer to tighten a screw, wouldn't it? The same applies to databases. You really need to consider what you're trying to achieve and what kind of data you're working with.
Okay, so no more one-size-fits-all approach. So what are some key factors to consider when choosing a NoSQL database?
First, think about your data model. How complex is your data? Does it fit neatly into tables? Or does it have a more dynamic structure? If you need a lot of flexibility, A document database might be a good choice. If your data is all about relationships, a graph database could be the answer.
Right, so understanding the shape of your data is crucial. What else should we keep in mind?
Next, you want to consider your query patterns. What kind of questions are you going to need to answer with your data? If you need to perform complex joins and aggregations, a relational database might still be the best option. But if your queries are more focused on retrieving specific documents or traversing relationships, a NoSQL database could be much more efficient.
So it's not just about the data itself, but how you need to access and analyze it. Is there anything else that we should be thinking about?
Scalability is another important factor. How much data do you expect to handle? And how quickly do you need to be able to grow your system? NoSQL databases are often designed with horizontal scalability in mind, meaning you can easily add more servers to handle the increased load.
So if you're dealing with massive amounts of data and rapid growth, NoSQL might be the way to go. This has been incredibly helpful in understanding all the different flavors of NoSQL databases. But is there anything else on the horizon? What does the future of NoSQL look like?
Well, the NoSQL world is constantly evolving. One trend to watch is the rise of multi-model databases, which combine features from different types of NoSQL databases, offering the best of both worlds, flexibility and specialized functionality.
Multi-model databases, they sound like the ultimate data Swiss Army knife. Anything else that we should be keeping an eye on?
Another exciting trend is the increasing integration of NoSQL databases with cloud computing platforms. This makes it easier than ever to deploy, manage, and scale NoSQL databases.
This has been a fantastic deep dive into the world of NoSQL databases. We've learned about all the different types, explored their strengths and weaknesses compared to relational databases, and even got a glimpse into the future of this really exciting technology. Any final thoughts for our listeners who are ready to explore NoSQL further?
Yeah, just remember choosing the right database. It's all about finding the best fit for your specific needs. Don't be afraid to experiment, explore different options, and find the database that empowers you to manage your data effectively.
That's a great point to end on. Thanks for joining us on this journey into the world of NoSQL databases. We hope you've learned something new and are excited to explore this ever-evolving landscape. Until next time, happy data exploring.